I hope you all remember how to divide this circle into 12 parts. Each division or each segment is 30 degrees, and you can divide it this way also, or you can divide it by arc way also. I have shown you one of the method, and this is another method to divide it. You can take 30-degree angles and then make lines and then mark the points. So let's move on. Now we have divided the circle into 12 parts, so we are going to divide the path QR into 12 parts. So one point will be corresponding to one point of P. Say P1 will be corresponding to 1 point on Q, that is 1. Then P2 will be corresponding to 2, then 3, 4, that will go on. Now we have 108 mm and we are going to divide it in 12 parts. So each segment has to be of 9 mm. Now each 9 mm say, how are we going to mark it? We are going to take 9 mm radius, put my point at Q and then cut an arc at 1, then cut an arc at 2. So let's see. Why are we taking this? The same animation that we saw last time will be more clearer with this particular points which are there. Look at this: first point, second point, third point, fourth point, fifth point, sixth point, 7 point, 8, 9, 10, 11, and R will be my 12th point. So I hope you got it. Okay, let's move on. So with center equal to Q and radius equal to 9 mm, I'll cut successive arcs starting from Q and moving on up till R. I've taken points instead of arcs to make the figure more clear, but you should make arcs, not points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 denote the points that are there on the circle. So now you can see each point corresponds to a particular point. Say P1 is corresponding to 1, P2 is corresponding to 2, P3 for 3, P4 for 4. Now we have these particular points of Q. Now for these particular points of Q, we need to find the position of P. Now if the position is Q, we have the position as P. Now what will happen when the position is at 1? Now we know that from Q till 1, when Q travels from Q to 1, particular P, the point particular P has moved 30 degrees. So it has moved up till from P to P1. Now from when Q has moved till 1, I need to mark the particular position of P1. Now for that, what will I do? Let's see the animation first, so you will get to understand. Now there will be different parts corresponding to different points. See, initial point is this point P. Then when it moves to 1, this is my first point. When it moves to 2, 3, 4, 5, 6, 7, 8, 9, 10, and correspondingly it will reach the final position R. Now again take a look at it very carefully. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 0, that is again R. Okay, so what will I do? The first point will be on P itself, so I marked it with a red dot, as you can see on the far left hand side of your screen. Again, now what will I do? I'll draw parallel lines from each point on the circle. Okay, from 1 and 5 it will be a similar line that will be passing. From 2 and 4 another similar line which will be passing. 3, now 3, 4 is already done, 5 is done, 6 is already the center of the figure. Now from 7 and 11 again the same line, 8 and 10 again the same line, 9 and 10 9 there will be again a same line. So we have the straight lines. Now why we are drawing this straight line? Now we will take the center point as 1. The next step, that is, we will take the center point as 1, radius equal to PQ, and cut an arc on the line which is passing through P1. So what will happen? It will give me 1 P1. That is my, say, position of P when my Q is at 1. Like this. This is my, say, 1 dash, and this 1 dash shows me the position of PQ when my Q reaches 1. So similar to that, I'll mark at 2. I have taken the radius as PQ, put my center as 2, and cut an arc on the line passing through 2. For 3, I have cut, this is the line, this is the parallel, this is the line 3, radius AB, cut an arc here, again join 3 dash. For 4, cut an arc on P4, line passing through P4, join 4 dash. For 5, for 6, For 6, that point will be on the same line, so it will be something like this. For 7, it will go above the line because the rotation has reached 180 degrees. Now it is going to go to 210 degrees. It will go to 240 degrees, that is 8. 270 degrees, that is 9. That is, say, perpendicular line, that is P9, corresponding to P9. Now again 300 degrees, that is point 10, 10 dash. 11. Okay, now we will see. Now we have joined this. Now we'll just have to join the points to make the line. So let's see animation starting till the end. Let's see the animation. What was there? A rod was rotating about a point, and that particular point was moving. So this is the point. These are the points of point Q that we got by dividing QR into particular segments. We'll see. Okay, now corresponding to that, we got points of P related to each position of Q. As you can see in the figure, the black dots denote the position of Q, and red dots denote the position of P. So again, this is the final. So now what will be the locus? Now it will be simple. Let's do all the things together so we get the locus. This purple line denotes the locus. So this is something that we will get in the final figure. The purple part is all that is required for us. So we have the required locus in form of the purple line. Okay, so we'll not stay back and we will draw the locus here also. So we have the locus. The more the smooth curve you have, the better is your solution. So remember that. The more smooth the curve, the better is the solution. Okay. Now the third problem, that was short because it was kind of easy, and this problem is even more easier. We had discussed 4-bar chain mechanism in which both the links were rotating. This is a similar problem, but if you remember, in that particular problem we had one link which was rotating clockwise and one link it was rotating anti-clockwise. Say the driver was rotating clockwise and the driven was rotating anti-clockwise. But here it is different. Here we have both the links, both the cranks rotating in the same direction. So I have taken both the links rotating in same direction, and we want to draw the locus of a point which is there beyond on the extension of the rod, connecting rod. So let's say two equal cranks AB and CD. AB and CD are two cranks, or say links, which are rotating, and they are rotating in same direction, and AB and CD are equal. So all these points are clear. AB and CD are cranks, both are rotating in the same direction, both have same length. Now what do we want to do? We want to draw the locus of a point Q which is on the extension of the rod beyond B. So say I have this rod and connecting rod, and I'll extend it beyond B. I'll draw my connecting rod beyond B for, say, how much? That is BQ is 300 mm. So I'll draw that 300 mm beyond B, and I'll put point Q and draw the locus of that particular point. So let's first see, the best thing that we do is see the animation. Okay, this is how it will look like. Both the cranks rotating in same direction. Now there is, now can anyone, by just seeing the figure, can anyone guess what will be the locus of this point? Well, keep this in mind. This is a question for you all to discuss. Right from this point, looking at the figure, looking at the animation, every one of you should be able to understand that this particular locus of the point Q or any point on the rod will be same. This is a hint that any particular point on the connecting rod beyond both sides, if you extend both sides, will be same. So, and it is a very common figure that you will be able to see on this particular screen also. So I have given a lot of hints, so you will be able to understand what will be the locus. Okay, I'll skip this part. Okay, let's move on. What is the first thing that we do? We draw a reference line of any length. So I have drawn this center line of any length. Now the next point is take a point A on the reference line. Point A is being marked on the reference line. Okay, and then with radius equal to AB, I will draw, that is 450 mm, I will draw a circle. and then I'll take any radius and that is mark it as AB. The next thing that I'll do is, in my question it was given the connecting rod is equal to the distance between the two centers. So with radius equal to 1500 mm, I will cut an arc on the reference line at point C, 1500 mm that is, and connect AC. Now I was talking about scale. Say if in this particular scale 1500 mm is 150 centimeters, so you cannot take 1.5 meters on a sketchbook. So you can take 1 mm is equal to say 1 mm is equal to 10 mm. That is 1 mm on the sheet is equal to 10 mm on in the question. So it will become 150 mm if you are taking a scale of 1:10. That is reducing. That is just for information. We are not going to apply it right now. Cut an arc on reference and then join AC. So this is my static link. Now next, with center is equal to C, draw, I know both the cranks are equal, so again with radius 450 mm, I'll draw a circle. We are going to move through this problem a little bit fast because the same steps have been followed in the previous problem also that we have discussed in the last session. So let's see, a few more steps to go. Now I'll join now with radius is equal to 1500 mm again, center is equal to B, I'll cut an arc on D. This is to mark the position of my connecting rod BD, and then join first CD, then I will join BD. So this is my initial position. Now I will divide my circle for the locus. I need to mark point Q, so it has to be beyond B for 300 mm, so I'll mark my Q according to that. Now I will divide my circle into 12 parts. 1 2 3 4 5 6. It goes on like a rhyme because each and every time you have to follow these particular steps. So by the time you give the examination, I think this must be a piece of cake for you all. So practice, that's what I want to say. Okay, now we have divided the circle into 12 parts. Now what we are going to do, same thing that we did when both the cranks are rotating anti-clockwise. Now first I will take the center as B1 and cut an arc on this circle. The radius will be equal to what? 1500 mm, that is BD. And I will do this for all the steps. Say I have marked D1, as you can see. I will draw the connecting rod B1 D1 and then mark point Q1, that is extended behind B1 for 300 mm. Moving on for Q, I have this for D2. I'll draw B2 D2 and I'll mark Q2. Then again for D3, the same procedure has to be followed and then it should go on. For B4, B5, B6, B7, B8, B9, B10, B11, and just go. Okay, so this is there. Now looking at the points, you will be able to guess that the locus of these particular points will be connected by, say, moving from B till moving from Q, Q1, Q2, Q3 till Q11. So the locus will come as a circle. I told you that you can take any point on the connecting rod, you can take any point beyond B on the connecting rod, any point beyond D on the connecting rod. The locus of this particular mechanism, or if it is there on the connecting rod or on the line of the connecting rod, will be a circle, because at each and every time B and D are at the same level. All the points on the line BD, if I extend B to infinity, D to infinity, and I mark different points, all the time these all points will form a circle. So this was the importance which was there. Now we have come to the end of the locus. What things do we have to remember? See, these particular points have to be remembered for drawing all the locuses. Take the measurements very carefully, very accurately. Again I mention very carefully, very accurately. If it is 5 mm, it should be taken as 5 mm. If it is 50 mm, it should be taken as 50 mm. You should not give you should not be careless in taking these particular measurements, because you are taking the measurements, you are marking the arcs, and then in the end, because of your carelessness, you don't get the figure. So there is no point in doing the hard work. So take the measurements very carefully, mark the arcs very carefully. See, once you have taken the measurement, you should take the center also. If the center is point A, then it should be taken as point A. It should not go 2 mm this side, 2 mm this side. If I go on doing this way, then you will say ki it is this way or it is this way. Then moving on, I'll join the lines. When you're joining the lines, say between 2 points, say from this point up till this point, if you're joining the line, it should not go, okay, I have this particular thing here, so I'll join from here till here, so it is kind of okay. No, this particular 1 mm difference also will be a huge difference at the end. As I said before, if you start with a 1 mm mistake, by the time you end the problem, it will be a 10 mm mistake, or it will be a totally different thing that has already been drawn. Now, one more thing, that while drawing the locus, there should be no sharp edges. The curve should come as smooth. Now, all these points, how are you going to conquer all these points? That is the next thing. This is about the next session. We are going to discuss engineering curves and drawing the conics. That is on 30th September 12 p.m. That is coming Sunday. And how are you going to get the remembering points very accurately? Only one solution: practice, 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 practice. Keep on practicing. The more you practice, the better you become. Okay, this is a very good thought that has been said by a famous scientist, that is Albert Einstein. Albert Einstein said that a problem once stated, the best way to solve a problem, once a problem well stated, is a problem half solved. You don't have to worry about the solution. If you state the problem well, you understand the problem well, then it is already half solved. If you don't understand the problem, it is not solved. So always read the problem very carefully before beginning the solution. If you don't do that, then you won't be able to solve the problem, because you might have missed some parameter. And you should remember, if you have in the problem, if you're stuck somewhere, stop the problem there, restart the problem, because you might have missed a certain point. So if you start checking one by one each and every step, it will take you more time. But if you restart the problem, you will be able to draw it in lesser time. Moreover, the number of steps that you have already covered you will be able to revise those steps. So instead of checking, if you draw the problem right from the scratch,